Hi Emma. What exactly is light microscopy, and what's its history?
Light microscopy is a technique for viewing and evaluating structures using transmitted or reflected light. It all started back in 1590 with Zacharias Janssen, a lens maker in Middelburg. Later, in 1665, Robert Hooke provided the first detailed account of the microscope, introducing the term cell, which means small room in Latin. Interestingly, Anton van Leeuwenhoek, a self-taught scientist, took things further by crafting over 500 lenses in his lifetime, becoming a pioneer of microbiology. The industrial production of microscopes began in 1847 with the Zeiss Company.
How does the light microscope work? And what kind of light does it use?
The light microscope uses visible white light, which is essentially a stream of photons with an average wavelength of about 550 nanometers. Human eyes can detect light in the range of 400 to 750 nanometers. The quality of the microscope heavily depends on the lenses and its ability to capture images. With light microscopes, you see a magnified, inverted, and virtual image of the specimen.
What is resolution, and how can we improve it?
Resolution in a microscope refers to its ability to distinguish between 2 points as separate. It's calculated by the formula equals lambda slash d equals lambda slash na, where d is the smallest distance between two distinguishable points. Lambda is the wavelength of the light, and na is the numerical aperture of the lens. The smaller the value of d, the better the resolution. So, reducing the wavelength, for example, by using a blue light filter or increasing the numerical aperture can enhance resolution. We also use immersion oil to improve it further. This oil, with a higher refractive index than air, allows more light rays to enter the objective lens.
How does immersion oil help exactly?
Immersion oil is placed between the lens and the slide to prevent light loss. When light passes through different mediums, like from the air to glass, some of it bends away and doesn't reach the objective. Immersion oil, with a refractive index close to that of glass, reduces this bending, allowing more light into the lens and thus improving clarity and resolution.
What about magnification? How is that calculated?
Magnification is the product of the power of the objective lens and the eyepiece lens. For example, if you're using a 40 times objective lens and a 10 times eyepiece, the total magnification will be 400 times. But keep in mind that useful magnification, where you can still see details, tops out at around 1,000 times for light microscopes. Anything beyond that is called empty magnification, where the image just becomes blurry.
What techniques can we use in microscopy?
Various techniques enhance what we can observe under a light microscope. Bright field. This is the most common and straightforward technique, where light passes directly through the specimen. Dark field. This highlights surface structures like cilia and flagella by blocking direct light, illuminating only the scattered light. Phase contrast. Great for visualizing live cells and tissue cultures as it amplifies slight differences in refractive indices. Polarization. Ideal for studying materials with a crystalline structure, like bone tissue. Fluorescence microscopy. Here, we use UV light to visualize structures tagged with fluorescent antibodies. Electron microscopy. Though it's not technically a light microscopy technique, it offers the highest resolution for observing the tiniest particles, using electrons instead of light.
What if we wanted to look at the smallest possible structures, like viruses or DNA? Could we still use a light microscope?
That would be pushing the limits of light microscopy. The resolving power of light microscopes is around 200 nanometers, which means you won't be able to see structures like viruses or DNA in detail. For that, you'd need electron microscopy, which has a much higher resolving power.
Thank you for listening. If our podcast has been valuable to you, we would greatly appreciate it if you could leave us a 5-star rating and write a review on Spotify and Apple Podcasts, or subscribe, like, and share on our YouTube channel. Your support helps us greatly with discoverability. We hope to see you soon.